Hello students, welcome back to the session. It is the last session from the operating system, like problem solving an operating system I would like to take, because all the topics from the operating system have been covered successfully till last session. So in this session I want to discuss some previous year questions from ECET paper. So look at the question here. What is a supervisory call? So from the introduction to the operating system I discussed. Supervisory call, SVC, when you run this SVC supervisory call, it will generate the software interrupt. When the software interrupt generated, what happened? ISR we have to run, interrupt service routine. So execution of ISR, what a mode shifting will take place, like we have to shift from user mode to kernel mode or kernel mode to user mode, right? So supervisory call is a privileged instruction I mentioned, right? Privileged instruction which will cause a software interrupt for shifting the user mode to kernel mode. So that we know, you read it. Call made by the admin of the system, wrong. So call with the control function is not a function. Call made by the user working in the root directory, no. Call used to perform the resource management functions. Resource management function meaning what? Suppose I want to use, please remember, I want to use what? Some resource of the operating system or fork. Fork I want to run it. So you have to shift from user to kernel mode to use the resource, right? So that such cases we have to use the supervisory call. So option 4 is the right answer. Look at next. Which of the following is true in the context of the thread? More number of user threads than kernel level thread can be supported. Means user level thread can be more than kernel level thread. Let's, whether true or not, we'll decide later. Context switching time between the kernel level thread is less than the user level thread. This is wrong. Context switching between the user and kernel level thread is taking more time than user level thread I mentioned. OS support is not required for implementation of kernel level thread. So it is required. Because kernel level thread is nothing but kernel support only required. OS support is required for scheduling a user level thread. This is not required. Hence statement 1 first option is right answer. User level thread can have a more number rather than what? Kernel level thread. Many to one support is a modeling is there, many to one, many user level thread and one kernel level thread, like this you understand. So which type of system call include the set time? Types of system call which we studied, like process control system call, device related system call, like communication related system call, information maintenance type system call. Under information maintenance I have discussed, no? Setting the time, setting the date, getting the system date, getting the system time, right? This comes under what? So it comes under what? Process related information maintenance, yes, it comes under maintenance. So other things you can remove it, yes or no? Suppose a process is blocked state, waiting for IO, some IO service, and when the service is completed, this enter into dash state. Process state transition diagram you have seen. Whenever running process required IO service move from running state to block state. Once IO or event is satisfied, the process will move from block state to a ready state. Which state will enter? Ready state. Ready state, yes. Semaphores are used to solve the problems of dash process synchronization, right? IPC synchronization mechanism we discussed. Semaphores are operating system resource which is used to solve the problems of what? Synchronization. Synchronization problems only we solve, right? Yes or no? So people generally confuse the critical section. Critical section is a part of this process synchronization. Yes, critical section problems only solve because we don't want enter the 2 or more process into critical section at the same time. We are ensuring by putting what? Protocols, entry and exit, right? So the critical section part of the process synchronization. People may confuse and choose a critical section, but you have to actually choose what? Process synchronization. In the page memory system, page hit ratio is 0.35, 35% they given. The time required to access a page in secondary memory access time is given 100 nanosecond. The time required to access a page in primary memory is 10 nanosecond required. The average time required to access a page is dash they are asking. Average time. First where they are asking, accessing main memory. So 35% is right, 0.35 is a 35%, iterate is there for what? They said no page iterate in main memory. Main memory access taking how much? 10 nanosecond. 35% is the hit rate. Miss rate is what? 65% or not? So 0.65. If miss occur in main memory, you have to get from secondary memory. Secondary memory access time what? 100 nanosecond. You should not include main memory access time because this is including everything here. 100 is include everything. So with this simplify, how much we'll get? 3.5 nanosecond plus. So 0, this will cancel. 65 nanoseconds. This gives 68.5 nanoseconds simply. So 68.5 nanoseconds, right? Look at next question. When second chance algorithm, not change mark, sorry, chance. This is a chance. Second chance algorithm is used for page replacement if all of the pages are already referenced, then it is equivalent to what? First come first serve algorithm. See, so I did not discuss this algorithm in the class because it is not available in syllabus, but rarely asked question. See, I'll tell you. We have a page replacement algorithm, FIFO, optimal, LRU, MRU. LRU approximation is there. Clock algorithm, second chance algorithm is there. Second chance algorithm is we have a reference bits will be there, ma. Reference and modified bit will be there. What happened? So when reference bits are 0, so all 0 bits will be chosen for page replacement. But second chance algorithm, what happens? First time when you referred, we won't replace that page. We'll give one second chance. When second time we referred, then we'll modify 1 to 0. Are you getting my point? Suppose one time I referred, ma'am. One time my page I referred, I made the reference bit is 1, 0 to 1, I make it. Initially all reference bits are 0. Whenever a page is referred first time, I am making R equal to 1, one time referred. Now whenever same page referred second time, we won't, whenever it comes for second time replacement, we won't replace it. We'll give a chance. Now second time reference is over, third time if refer again, we are making the reference bit is 0. Whenever all reference bits are 1 are going to be zeros, now it is acting like a first in first out. We have to choose a first in first out method is for replacing a page. So that is the reason. So when that's a page replacement, if all the pages are referenced, all referenced over, now all become 0, you have to go with first in first out algorithm only. Which disk scheduling algorithm performs better for system that place heavy load on the disk? I discussed, right, scan algorithms. So first come first cannot be, look cannot be, shortest seek time cannot be, C-scan, circular scan. Circular scan. When a heavy system a heavy load, heavy requests are there, it will go till end. Then reverse timeout, it won't service, right? It won't waste our time for checking the requests are serviced on. It will come back to quickly other end, again starts. Heavy loaded system, C-scans performs better. Which of the directory system it is possible to have multiple complete path for a file starting from the root? Directory structures we have seen. Single level directory, two level directory, multi-level and acyclic graph directory structure we have seen. In which case we have multiple paths for a file. So wherever direct link is there, now from here to there, we have multiple paths or not. So that is possible where acyclic graph directory structure or not. This way we can answer it. Look, the disk request comes to disk for the cylinder in this order they given, and the disk drive is reading from cylinder at 20. The seek time is 5 milliseconds per cylinder. The total seek time if the disk harm scheduling algorithm is first come first serve. How many cylinders are there? The disk request comes from the disk drive for the cylinder in the order 10, 30, like this only. So suppose you keep it like this only. We don't know how many, but we can mark it. What is the initial request is there? So smaller request you can tell somewhere it is 10, okay, somewhere this is 30, this is 50, this is 60, somewhere 70 like this, okay. Now cylinder is at 20, here is a 20, okay, 20, okay. First come first serve. What the first, in this order, first request what 10, so you have to service here 10, fine. 10, then 30, then 30, then 60, then 60, okay, 60. Then after 60, 50 requests, then 70, it will go like this, no? First is 20, at 20, 22 become for 10, 10 to 30 will go, 30 to 60 I will go, 60 to 50 will come, 50 to 70. Number of seeks happen how many? 20 to 10 is 10, plus 10 to 60, 50, from 60 to 30, from 60 to 50 I came 10, plus 50 to 70 I went to 20. Total how many happened? This is 60 plus 10, 70, 70 plus 20, 90. 90 millisecond happened. 90 into each had a 5 millisecond. 5 millisecond. This goes 9 5s are 45. 450 milliseconds. 450 milliseconds. Yes, option is the right answer. This way we can do it. Simple, right? Simple question. The Banks algorithm is used to rectify the deadlock, to detect the deadlock, to prevent the deadlock, to solve the deadlock. So please, Banks algorithm we are using where? Deadlock avoidance only, right? Avoidance. So to rectify a deadlock, rectify is not suitable. Detecting, not, we are not using detecting. Yes or no? Detection algorithms we have. To prevent a deadlock, we are not using Banks algorithm. To solve deadlock. To solve a deadlock problem, I should not use the word solve, but in case of detecting algorithm we using or not, to detect the deadlock algorithm are we using or not. So multiple instances case, there is a detection algorithm, we use a weight for graph, even Banks algorithm also we use for detecting the deadlock also, right? Not solve. This is a not correct terminologies, I can go for to detect deadlock also we use Banks algorithm. First in first out scheduling is non-preemptive scheduling. Preemptive scheduling is not preemptive. First share scheduling, deadline scheduling, this is a non-preemptive scheduling. Directly, easy question. Look, next question. The time interval from the time of submission of a process to time of completion of a process termed as turnaround time. We have discussed. I given clearly what is the waiting time, response time, throughput, turnaround time, nothing but completion time minus arrival time, also known to be submission time. We can tell submission time also. Next. Computer system has 6 tape drives with n processes competing for them. Each process may need 3 tape drives. The maximum value of n for which system is guaranteed to be deadlock free. Same question I discussed in the concept time. How many n processes are there? We don't know. We need to find out n. So let's take suppose n value if I take 3, P1, P2, P3. Okay. How many demanding? Each process may need 3 tape drives. 3, demanding 3. Then maximum value of n. They said the computer system has 6 tape drives. Already 6 is there. They are demanding 3. Suppose the demanding what? Suppose 3 demanding. Okay. Now see. Now, how many m value? How many 6 are there? Okay, 6 are there. How we can allocate 3? Suppose if I take, so I can give 2. Can I give 2 copies? 6 over. I don't have 1 copy to give, so I cannot satisfy with even 3 process also. Suppose if I take only n equal to 3, n equal to 2, so 2 process P1, process P2 only. Maximum demand is 3. Okay, what I will give? There a demand minus 1, I'll give it 2. Demand minus 2. Total copies how many are there? 4 copies given. Remaining with me how many? Total 6 copies we have, right? So 4 copies given, 2 copies were there. 1 copy I can give and satisfy. 1 copy given, it will satisfy, right? So with n equal to 2, no deadlock. If I take n equal to 3 process, P1, P2, P3, their demand is 3, right? Each process may need of 3 tape drives. 3 demand is there, 3. Maximum value of n they are asking. 3 is there. So demand minus 1, demand minus 1, demand minus 1. If you give 6 copies over, I don't have an extra copy to give. If could have system has 7 tape drives, I could have satisfied 3 process without any deadlock free operation. But we have 6 copies only. You cannot run the 3 process. If 3 process, they demand 3 copies, right? So how allocation goes? Maximum minus 1, we have to give it. Correct. If I give it now, 6 already over, I don't have 1 extra copy to give another process. So n equal to 2 only possible. Option 2 is the answer, please understand. The address space of a page table in a memory is pointed by dash. Stack pointer, no. Page register, no. Program counter, no. Page table base register, yes. In a paging concept, no page table is there, right? Page table address we are storing in a page table register, please understand. Page table register pointing the page table address. This we need to understand, all of you. A multi-level page table is preferred in comparison to a single level page table for a translation virtual address to physical address. We discuss multi-level paging. Why we have discussed? Performance of simple paging case I discuss. To solve the internal fragmentation page table overhead, there are two solutions. Finding the optimal page size. Second one is what? Multi-level paging. Multi-level paging. So now see, with respect to understand, it reduces the memory access time to read or write a memory location. No, it won't reduce. It will increase. To help to reduce the size of the page table needed to implement the virtual address page. Yes, it will reduce the size of the page table. It is required by the translation look-asset buffer. No. To help to reduce the number of page faults in a page replacement algorithm. No. So multi-level paging reduces the overhead of the page table sizes. Please understand. Because when you do paging on page table, some internal page table we are keeping secondary memory. So that hence page table overhead is required less in case of multi-level paging. This way you can answer it. In the dash algorithm, the disk arm start at one end of the disk. One end of the disk moves toward the other end, servicing the request till the other end of the disk. At the other end, the direction is reversed and service is continued. Which one? Scan or not? Scan. Scan case only it will go directly other end, and reverse time also will service. They said, the direction is reversed and servicing continues. Servicing continues. In case of C-scan, reverse time service is not continued. You may get a doubt, C-scan also same will go, sir, one end to other end. But once it reaches other end, when we take the reverse direction, it won't service, it will complete directly, circular, it will complete first location. Scan case only reverse direction also will service. So suitable answer for this question is what? Scan algorithm. A running program requests the service from the kernel of the operating system using dash system calls. Yes or no? Whenever I give a same line, whenever user process requires a service from the system, from the operating system via system call, translation must be made from user mode to kernel mode. So through system call only you can take a service from the operating system. System call, directly answer. This is not functional call, not procedure call. This all are this all are user level. This is interrupt mechanism. This is not correct. Which of the following is a false with respect to the indexed disk file allocation method? We have seen three methods: contiguous allocation, non-contiguous, linked allocation, indexed allocation. Among three, they are talking about indexed allocation. It supports both sequential and random access. True. It eliminates the external fragmentation. True. It has a space overhead in the form of index block. Yes or no? Space overhead. For each file, there should be separate index file need to be allocated. It is not highly reliable. It is actually reliable. It is highly reliable. So he is saying not reliable. This option is false. Which is false? This option is false. Look at it. The aim of creating a page replacement algorithm is to dash. What is the objective of studying the page replacement algorithm? To minimize the number of page faults only, right? Replace the page faster, increase the page fault rate, wrong, decrease the page fault rate. To allocate the multiple pages to a process, no. Replace the pages faster. So replacing pages faster done by the hardware mechanism, because what? The speed up, but not by the replacement algorithm. Replacement algorithm aim to reduce the number of moves, number of page faults only. That should understand. So this way we can discuss. Let's some more problems I want to take into in second session, next session. Fine. So thank you so much.